Hello everyone, welcome back to another lesson. Today we're going to talk about rotations. In the previous two lessons we talked about reflections and translations, okay? First thing we're going to do is how do we rotate just any point without an XY graph? Alright, that's what I want to show you first. And go through some proper terminology. We'll do a couple examples on the XY plane. Alright, sound like a plan? Alright, so if you have a protractor, this is awesome. Okay, if you don't have a protractor, then I guess you just have to sit and watch this for right now, okay? And you're also going to need a ruler. So what I want to do, okay, I want to rotate point A in respect to this guy right here. Okay, we call this the center of rotation. Okay, a good way to think about this is a clock, okay? All the hands on a clock, okay, your second, your minute, your hour hand, okay, they are all in respect to the very middle of that circle that they're going around, right? That's where they're rotating. Same thing here. So I'm going to rotate with respect to this point. Now, when we get to an XY plane, it's going to be the origin. But for right now, it's that point, okay? And just randomly, I'm going to rotate this 60 degrees counterclockwise, okay? Now, I'm going to abbreviate counterclockwise as CCW. Makes it a little bit easier. So that we don't have to rewrite that word constantly. All right, abbreviations are awesome. Now, what I'm going to do first, all right, to perform this rotation, I'm going to take my ruler, okay, and what I'm going to do is I'm going to measure, and I'm going to cheat a little bit, okay. I'm going to make this an easy measurement for me to work with, okay. So from this point to point A, okay, if I take a look, it is going to be 6 inches. And I'm also going to draw the line. So I'm going to draw the line that connects these two, and I'm going to put down that they're 6 inches away. Okay? Now, that line is going to help me with my protractor. So you're going to put your protractor right here on the line, okay? And when you're doing this, you want to kind of keep the center of the protractor right where the center of rotation is, okay? You're going to measure out 60 degrees. Since we're going in this direction, this is 0, and you're going to read the bottom numbers of the protractor, okay? So you're going to go up to where 60 is. I'm going to make a little mark right there to indicate that that's where 60 degrees is. Take the protractor away, okay? Now, using my ruler, I'm going to measure out 6 inches, but before I do, I'm going to go ahead and just connect that little mark that I made all the way down to here. Then I'm going to use my ruler, okay, measure out 6 inches, which would be right here. That's where A prime is going to be for me. And then I'm just going to erase the rest of it, all right? Get rid of all the extra segment. I don't need that. And there we go. So I went from this point right here all the way over here, 60 degrees. Okay? The distance that A prime is to the center of rotation is the same distance. Okay? That's very important when you do a rotation. And whatever your points are moving, whether it's clockwise or counterclockwise, 60 degrees, 90, whatever, it has to be equally distant to the center of origin. Or center of rotation. Okay? And that's how you do a rotation without using a graph. Okay? Pretty cool, huh? Now, let's use a graph. That's what this whole lesson's about, huh? Is how can we use an XY graph to rotate objects? We're going to do 3 types. We're going to do 90, 180, and 270. We'll talk about the rules, which you can use, or you can try this technique that I'm going to show you, which I think is pretty cool, to be perfectly honest. Here we go. And I'm bringing back the projector. Boom. It's back. I love this thing. This is my first example, and you're going to have to pause the video. I'm just going to keep going. And we're going to rotate this 90 degrees counterclockwise. If you're ever confused as to what direction that is, look at a clock. Look at the second hand. Okay, it's going to go against where the second hand's going. So in other words, I'm going in this direction, okay, counterclockwise. Looking at my pre-image, what I'm going to do is use the graph to my advantage, okay? Think of it this way. If I were to Oh, let me look at the other side so you can see this better. If I was to rotate this entire graph 360 degrees, okay, for me to do that, see how I had to rotate this or turn this 4 times to get to 360, okay? So if I turn this just once, notice I rotated my entire graph 90 degrees, okay? If I were to turn this twice, okay, now I just rotated this graph 180 degrees. If I do it 3 times, you would probably guess, hey, Mr. McCullough, that's 270, and then 4 times gives you back to the original, which is 360. That is not straight. That's going to bother me. What that's telling me is that each turn is a 90-degree angle that I'm rotating there. Does that make sense? Okay, since it's going to be equally turned 90 degrees, we're assuming that each one's going to be congruent. Now, if I want to rotate 90 degrees counterclockwise, all I'm going to do, okay, is turn this paper in this direction right here. So I'm going to turn it once, okay? That is what it's going to look like. Hey, we got an actual picture. If you're not a visual person, this is I think is perfect to actually see what does this look like actually rotated. It looks like this. Now, how does that help us? Because we still got to graph it, right? Well, this is like a copy and paste method. This is my temporary x and my temporary y-axis. Notice I didn't really number these, and I didn't write x or y-axis for this reason, okay? Now, look at where point P is. Okay, its new position is going to be -1, 1. Up here, I'm going to write that down. -1, 1. I'm saving the coordinates for later. Q, all right, is going to be -5, 4. That's where Q prime is going to be. And then R prime, I'm going to go -1 and then up 5. Okay? This is the copy part of the copy and paste. Okay? Now, once I have those coordinates written, I'm going to move my shape back to its original position. Okay? And I'm going to now, quote unquote, paste the object. I'm going to take these points and graph them. So here's P prime, 2, 3, 4, 5. Here's R prime, and then Q prime, 1, 2, 3, 4, 5, 1, 2, 3, 4. There we go. Okay. And now we connect the points and marvel in what we just see. Just amazement. And there we go. There is my 90-degree counterclockwise rotation of that triangle. And notice, and I said this before the beginning of the video, but my center of rotation is the origin. Okay, that's where we're doing this. So therefore, if I measure each point to the origin, it will be equally distant, the pre-image and image points, okay, individually. They're not all going to be the same, but in respect from this guy to this guy, it will be the same, right? R to R prime will be equally distant to the center. All right, that's it. That's the trick. Now, let's do a rule, all right? If you take a look at our coordinates here, okay, I can see that what they're doing is they're flipping them, right? They're going to flip the coordinates. But look at the y-coordinate. See how the y-coordinate now becomes negative? So I'm changing the sign. Now, for notation purposes, that doesn't mean it's always negative. That just implies whatever the sign is, you change it. So if it's positive, it becomes negative, negative becomes positive. There's the rule for rotating an object 90 degrees. You can write the coordinates first, then graph it, or what we just did now, you could rotate the paper to make it that point. Now, if I rotate this 90 degrees, you can see that it matches up perfectly. Okay, so we did our job. Hooray! It's correct. First example done. What do you think? Not too bad? Questions, thoughts, concerns? Oh, I'm sure you're okay. I think you're good. All right, ready for round 2? We did 90, so we're probably going to do what? 180? Example 2. Okay. This is going to be a parallelogram. Okay, so those are the points. And I'm going to go ahead and graph this myself. You don't have to pause the video this time because, well, I have to graph this. So the time it takes me to graph it would be the time that you can graph it yourself. I'm done. Are you done? Not that it's a race, but all right. Here's my pre-image. That's what I'm starting with. And I'm going to rotate this 180 degrees counterclockwise. And then we're going to make an observation at the end, which is pretty cool. Now, if I'm going to do this, I have to turn my paper. Now, every time I turn it, it's 90 degrees. So therefore, I have to turn my paper twice. And I have to do it. Oh, sorry. Sorry, I just got choked up over this. It's beautiful. You're going to go counterclockwise in this direction. Okay? Here we go. So, turn it once. That's what it looks like with a 90 degrees rotation. Turn it twice. This is what it looks like with a 90-degree rotation. Okay? Once again, temporarily, this is my new x-axis and y-axis. Okay? And we're going to write down the coordinates. This is the... I don't think there is a method for this. I call this copy and paste because it kind of reminds you of it in a way. Okay, f prime is down here. That's going to be a -2, -1. Okay. G prime is -7, -1. H prime is -6, +3. J prime is -1, +3. If I just read those coordinates off, that's what they are. All right, now we're going to move this back to its original position. We did the copy part, right? We copied down what the coordinates are going to look like. Now we have to paste, okay? With it back to its original position, this is now my x and y axis again, okay? That's why, once again, I don't number these or label it for that reason, because if you do, it can get confusing when you're rotating your paper. All right, now let's plot these. Let's see. So f prime is here. Let's see. 1, 2, 3, 4, 5, 6, 7. Down 1. So there's G. 1, 2, 3, 4, 5, 6. 1, 2, 3. So there would be H prime. And you could pause the video and skip this part if you already have it graphed. And then last one, -1, 3. So right here would be J prime. I think I moved H prime was just a little bit too high there. Okay. Connect the dots. Remember doing that back in your elementary school days, kindergarten days, connecting the dots, seeing what the picture is? I missed those. They were fun, weren't they? And there we go. There's my resulting graph. Pretty cool, huh? Let's make a rule as to what we're seeing here. If I look at these coordinates, I didn't switch them at all, huh? The numbers stayed in the right positions. The only thing that changed was the signs, right? They all became opposites of each other. Therefore, my rule would be take the opposite of the x and y coordinate. There we go. Which you could memorize that rule and know that for future, but I'm not a fan of memorizing when it comes to mathematics. I would like to have a method that I could use years down the line, okay? One little, can I make one note, please? Can I make one note? Yeah? Oh, you guys are awesome. We went counterclockwise, right? Now, watch me do this. I'm going to go the other direction. Let me go clockwise for a second. So here's 90. And then here, oh, I went too far, sorry. Here would be 180. Now watch what I could do. Hopefully, if I can get this to work. Okay? I can get this to line up to where it is the same. Now, unfortunately, I can't. Close. A little bit close. I think I might have graphed. When I graphed my points, I think I might have went a little bit too far with the one set of coordinates. But I can see that it does overlap nicely. Okay? Therefore, I could say that 180 degrees counterclockwise is the same as 180 degrees clockwise. It doesn't really matter the direction you go with that. Okay? Now, would you remember that in the future? And maybe you might. But I would just remember counterclockwise. Okay? But that's kind of a cool observation. What do you think? One more problem? Grand finale? What do you think we're going to do? Come on. Shout it out. 270. Yes. We're going to rotate an object 270 degrees. Let's go ahead and do that. Example 3. Okay. We're going to go back to a triangle. I know, not as fun as a quadrilateral or a hexagon. We could do all kinds of shapes, to be honest, but we tend to stick with triangles because it's just quicker to graph. That's the only reason, guys. That really honestly is. Okay, go ahead and graph this. I'm going to graph it myself. No race, but I'm starting now. Let's see if you can beat me. Done. What do you think? Did you beat me to it? Did you graph this before I did? Probably did. It's hard to graph when I don't have lines on here. So when I'm spacing it out, it can be a little difficult, like you saw in the last example. They were supposed to line up perfectly, so I must have just missed the mark just by a little bit. Okay, 270 degrees. That means I'm going to turn my paper 3 times, right? Each one's 90 degrees when I rotate it. So let's go ahead and do that. So I'm going in this direction. So here we go. 90, 180, 270. There it is. Okay? That's what it's going to look like. Now let's just copy the coordinates down. Remember, this is now my temporary x-axis. This is my temporary y-axis. That's why I don't like to mark these with numbers or label x and y-axis for that reason. I keep it like a blank page. Okay, J prime is going to be at 6, -2. If I'm looking at this. K prime is going to be at 2, -5. And finally, L prime is going to be at 5, -7. Okay? So far, so good. Bringing the object back to its original position, which looks like this. Okay. Now I'm going to take the coordinates that I copied and I'm going to paste them and see what it looks like, and hopefully it is what I just seen. So 1, 2, 3, 4, 5, 6 down. Oh, sorry. 1, 2, 3, 4, 5, 6 down 2. That's J. 2, 1, 2, 3, 4, 5. There's K. And then 1, 2, 3, 4, 5, 5, 6, 7. Okay. There's there's an L, which, let me double check that last one. 1, 2, 3, 4. Yeah, that looks like it's lined up. Okay. Well, that's not going to work. Boom. There we go. Once again, let's go ahead and write a rule. What are we observing here? What's happening to the coordinates? Well, I noticed that the x and y coordinates are flipping. But this time, it looks like it's not the y coordinate, but the x coordinate. When I switch them, I'm also changing the sign. So this is going to be my rule, okay? You're going to flip them and then make the x coordinate become the opposite sign, okay? 2 things, and then we're done, okay? I promise you, we're almost there. 1, could I get to this differently? I went 270 degrees this direction, but I can get to here a little bit faster, right? What if I went in this direction clockwise? I only have to turn the paper once, right? So wouldn't a 90-degree rotation get to me at the same exact point? I think so. Ta-da! Okay, I'm trying, guys. It's hard to... There we go. Okay. Wow. I got a phone call. I'm recording. What the heck's going on here? Sorry about that. So yeah, here it is. It lines up. I know it's not perfect. It's hard to gauge this when I'm doing this live. It's easy to do it when I'm not recording, but anyway. But yeah, we could go 90 degrees clockwise and get the same result. Go ahead and write that down, okay? So 270 degrees counterclockwise is the same as 90 degrees clockwise then. All right? That's it. That's rotations, okay? Not too bad, right? If they do not tell you what direction to go in, always assume it to be counterclockwise. Okay? Unless they tell you clockwise, always go counterclockwise. All right? That's it, guys. So, hope you're having a good time. Hope you're doing well. And I will see you all in the next lesson video. Thank you.